Hi, in this video we're going to solve Pure Maths 3 paper from May-June 2022 series. Let's have a look at the first question. Okay, I will take a natural log of both sides. And then I can use lots of logs to split the left side. So I get log 2 plus log 3 to the power of 2x minus 1 equals to log 4 to the power of x plus 1. And then again, using logs of logs, I can move the power in front of the log. Next, I will expand the brackets. And then I will collect all terms with x on the left side and everything else on the right side. Next, I will factorize the left side and take x out. So get x times 2 log 3 minus log 4. And again, using lots of logs, I can combine the right side into one log. Technically, you don't really have to do it, but it just looks nicer if you do. So I will get natural log. When I'm adding logs, that means I will have to multiply. So it's going to be 4 times 3, which is 12. When subtracting, I'll have to divide. So 12 divided by 2 is 6. You can also simplify the expression in a bracket, but I don't think I will. I'll just divide by the whole bracket. And that equals to 2.21. And I'll give this as the final answer for the very first question. Question 2 is about generalized binomial theorem, and you can find the formula in the formula sheet. Here it is. But the only problem is, before I start using the formula, I'll have to get one on the left side of this bracket. So what I'm going to do is to factor out 2, and I will get 1 minus x squared over 2. And all of this to the power of minus 2. Now we can write it as 2 to the power of minus 2 times the bracket 1, and I'm going to use plus to make it look more like the formula, minus x squared over 2 to the power of minus 2. Now 2 to the power of minus 2 is 1 over 2 squared, which is 1 over 4. And then I can start using the formula. So I will get 1 plus, and here we have to be really careful with plus and minus sign. So n equals to minus 2. So I'll get minus 2 times x in the formula. And in my case, it's minus x squared over 2. Plus the next term in the formula is n times n minus 1 over 2 factorial times x squared. So again, n is minus 2, so I get minus 2. Minus 2 minus 1 is minus 3 over 2 factorial. And then square minus x squared over 2, that will be positive x to the power of 4 over 2 squared, which is 4. Now, we have to expand up to n, including the term in x to the power of 4. That means I don't need to get any more terms. Now, all we have to do is to simplify this a little bit. So we'll get 1 over 4 times 1 plus, minus and minus will be plus, 2 cancels out, so 1 plus x squared. Next term, again, it's going to be plus 2 times 3 is 6, x to the power 4 over 2 factorial is 2 times 4 is going to be 8. Let's simplify it. 6 over 8 divided by 2, 3 and 4. And let's multiply everything by 1 over 4 and get the final answer. It is 1 over 4 plus x squared over 4 plus 3x to the power 4 over 16. Done. Okay, in question B, we'll have to state the set of values of x for which our expression is valid. Now, how to do it? First of all, look at the formula, and we'll see that our formula works for the absolute value of x is less than 1. But in our expansion, we don't have 1 plus x. Instead, we've got 1 plus negative x squared over 2. So that means negative x squared over 2 absolute value should be less than 1, and we'll have to solve it. Now the absolute value will remove the negative sign. I will get x squared over 2 less than 1. I will multiply both sides by 2 and get x squared is less than 2. Now moving on, I will subtract 2 from both sides, so I have to solve x squared minus 2 is less than 0. Now, whenever we're solving quadratic inequalities, I recommend thinking of the sketch of the curve. So this is x-axis, and it opens up. We're looking for the values of x for which the quadratic is less than 0, so it should be below the x-axis. Okay, so that means x is going to be in between these 2 points. Now, those points are when x squared minus 2 equal to 0. Solving this gives us x squared equals to 2, or x equals to plus or minus square root of 2. So that means the answer is x is in between negative root 2 and positive root 2. Okay, let's move on to the next question. Trigonometry. To start with, I want to rewrite cotangent as tangent. So cotangent x would be 1 over tangent x. That means our equation will look like 2 over tangent to x plus 3 over tangent x equals to 5. Now I will multiply both sides by tangent x and tangent to x. So that means I will get 2 times tan x plus 3 times tangent to x equals to 5 tan x tangent to x. Okay, next, I don't want to have tangent x and tangent to x, so I can use the double angle formula for tangent, which is tan to x equals to 2 tan x over 1 minus tangent squared x. Okay, so I will replace tangent to x with this expression. I will get 2 tan x plus 3 times 2 is going to be 6 tangent x over 1 minus tan squared equals to 5 tangent times 2 tan x divided by, again, 1 minus tangent squared. Next step. When we have fractions, we don't really like it, so I will multiply everything by the common denominator, which in this case is 1 minus tangent squared. So I will get 2 tan x times 1 minus tangent squared in brackets plus 6 tan x equals 2. 5 times 2 is 10 tangent squared x. Now expand the brackets to tangent cubed x. And then I will move 10 tangent squared x to the left side, and I will get plus 6 10x minus 10 tangent squared x equals to 0. Let's simplify this a little bit. Get minus 2 tangent cubed x, then minus 10 tangent squared plus 8 10x. Now, I don't really like having minus in front of the leading coefficient, so I'll multiply everything by minus 1, and I will get plus, and instead of plus 8, I will get minus. So just quickly erase this plus. And then to solve this cubic equation, I will factorize. So bring 2 tangent x outside, and I will get tangent squared plus 5 tangent x minus 4 equals to 0. Okay, so now the product equals to 0 when either tangent x equals to 0 or when the bracket equals to 0. The first equation will give us x equals to 0, or when you're solving equations with tangent, you can always add or subtract pi radians or 180 degrees, in our case, degrees. I can add 180, so x1 is 0, x2 equals to 180 degrees, but look at the range of x. It should be from 0 to 180. That means both of them are out of range, so I'm not considering those. Now, moving on to this equation, I'll make a variable change and say that tangent x equals to t. So I get t squared plus 5t minus 4 equals to 0. And I'm going to use quadratic formula to solve it. So t equals to minus 5 plus or minus b squared minus 4ac is going to be 25 plus 16 over 2. If I take the plus sign, that will be 0.70156 and so on. But remember, t is tangent x. So I will have to take the inverse tangent of this. And that gives me 35.05. And if I take the negative sign in the formula, that will be t2 equals to minus 5.701 something. Then I will take the inverse tangent of that. That brings us to minus 80.052. Again, don't forget you can always add or subtract 180 degrees to your answer. So to get in range, I will add 180. And I will get x equals to 99.9 degrees. And then let's state all values of x which are in range as the final answer. So I will get 35.1, correct to 1 decimal point, and 99.1. 99.9 degrees. Okay, that's the answer for this question. Let's move on to the next one. Question 4 is about differential equations, and if you're not sure how to get started, I've made a video about differential equations and variable separation, so check it out. But I will start by multiplying everything by the common denominator, so I'll get 1 plus x squared times dy equals to xy dx. Now, I will have to separate the variables and collect all x next to dx and then y next to dy. So I'll divide both sides by 1 plus x squared. And I will get dy equals to xy dx over 1 plus x squared. So now I got x and dx on one side, but I don't want to have y on the right side. It should be on the left. So I will divide both sides by y. That gives me 1 over y dy equals to x over 1 plus x squared dx. Now, the variables are separated and I can integrate both sides. Integral of 1 over y dy is going to be natural log y. Then the integral of the right side is a bit more complicated. You'll have to remember this formula. Integral of f derivative over f is going to be natural log of f. Now, let's differentiate the bottom part of this fraction, and we'll get 1 plus x squared derivative equals to 2x, which is kind of the same stuff as on top of the fraction, but apart from the 2. So what I'm going to do is I will sneak in 2 on top, but then in order to not change anything, I will divide by 2. So I'll put 1 over 2 in front of this fraction. Now, integrating this gives me 1 over 2 natural log of 1 plus x squared. Don't forget the c. Now let's find c. We know that y equals to 2 when x is 0. So I can substitute 0, 2 into the equation, and I will get natural log 2 equals to 1 over 2 natural log 1 plus c. Now, natural log 1 is 0, so that goes away, and we got c equals to log 2. Now, let's put it back into the equation. Log y equals to 1 over 2 natural log 1 plus x squared plus log 2. Okay, what do we have to do? I have to obtain a simplified expression for y in terms of x. So let's combine all logs together, bring 1 over 2 up as the power of 1 plus x squared. Log y equals to natural log of 1 plus x squared to the power of 1 over 2 plus log 2. Now, if you're adding logs, that means you can combine it as 1. So it's going to be multiplication, log 2 times, and then the power of 1 over 2 is the square root. So get 2 times the square root of 1 plus x squared, and then it equals to log y. And then from here, you can just remove the log and say that y equals to 2 times the square root of 1 plus x squared, and that's the answer. Let's move on to the next one. This one is about polynomials. So p of x equals to ax cubed minus 10x squared plus bx plus 8, and x minus 2 is the factor of both p of x and p derivative. Okay, let's find p derivative. That's going to be 3ax squared minus 20x plus b. Now, according to the factor theorem, if x minus 2 is a factor, then we can make it equal to 0, find a solution, and then substitute it into both polynomial and a derivative, and the result should be 0. So p of 2 should be 0, and p derivative of 2 also must be 0 because of the factor theorem. And as our key to this question, let's start by substituting 2 into the polynomial. We get p of 2 equals to 8a minus 40 plus 2b plus 8. And let's make it equal to 0 and do the same for the derivative. P derivative of 2 becomes 12a minus 40 plus b. And again, I'm going to make it equals to 0. So we've got 2 equations, 2 unknown values. That's simultaneous equations. And I will start by dividing the first equation by 2. So I can get the same coefficient next to b. I will get 4a minus 20 plus b plus 4 equals to 0. And the second equation is 12a minus 40 plus b equals to 0. Simplify it a little bit, and we get 4a minus 16 plus b equals to 0. And then 12a minus 40 plus b equals to 0. Now, I'm going to subtract the first equation from the second one. 12a minus 4a is going to be 8a. Minus 40 minus 16, which is plus, is going to be minus 24. And then b minus b is 0. That's exactly what I wanted. And then on the right side, we got 0. So 8a minus 24 equals to 0. Solve it for a. And we get a equals to 3. Okay, now we can substitute this into, I would say, the first equation, this one, to get 12 minus 16 plus b equals to 0. That means b equals to 16 minus 12, which is 4. And the answer is going to be a equals to 3, b equals to 4. Next question. When a and b have these values, factorize p of x completely. First of all, let's substitute a and b into the polynomial, and we'll get 3x cubed minus 10x squared plus 4x plus 8. And also the question says that x minus 2 is the factor of this polynomial, so that means it can be divided by x minus 2. And that's exactly what I'm going to do. I'll divide it by x minus 2. Okay, I will have to multiply x by 3x squared, so I can get 3x cubed. Let's do that, and I will get 3x cubed minus 6x squared. Subtract. 3x cubed minus 3x cubed is 0. Minus 10x squared minus minus, which is plus, becomes minus 4x squared. And then I'll just copy 4x plus 8. Again, look at x minus 2. I will have to multiply it by minus 4x, so I can get minus 4x squared. When I do this, I get minus 4x squared plus 8x. Subtract. X squared cancels out. 4x minus 8x becomes minus 4x plus 8. And then finally, I'll have to multiply by minus 4. And I'll get minus 4x plus 8. Subtract equals to 0. Okay, so the first step is done. And we get our polynomial as x minus 2 times 3x squared minus 4x minus 4. But this is not factorized completely because we can also factorize quadratics. Okay, how do I factorize quadratics? We're going to have two brackets. Now, whenever I'm multiplying, I should get 3x squared. So I would say we're going to have 3x on the bracket on the left side and x on the right bracket. Now, when I multiply the numbers, I should get -4. There are multiple ways to do so. It could be like 1 and -4. It could be as well 2 and -2. And I think I'll just take a guess and say that it's going to be +2, -2. I want to check it out if I'm right or wrong. So it's 3x squared minus 6x plus 2x minus 4, which becomes 3x squared minus 4x minus 4. Okay, so my guess was correct. That means our polynomial becomes x minus 2 times 3x plus 2 times x minus 2. And then we can combine the x minus 2. That will be x minus 2 squared times 3x plus 2. That's the final answer. Okay, let's move on. We got question 6, and it's about integration by substitution. So that means we'll have to rewrite the original integral in terms of another variable theta. Let's start. So we're going to have the integral 27. I will start by replacing x with 3 tangent theta. So I got 27 over 9 plus 9 tangent squared theta dx. Now, we'll have to rewrite dx in terms of d theta, and in order to do so, I'll have to differentiate x with respect to theta. So I'll get dx over d theta equals to 3, and then derivative of tangent is secant squared. And from here, I can find dx. dx equals to 3 secant squared theta d theta. And I'll replace dx with this expression. So we'll get integral 27 over 9 plus 9 tangent squared theta. And I think I missed the square. Yeah, I did. Here, squared square. And instead of dx, we're going to have 3 secant squared theta d theta. Now let's simplify this. 27 times 3 is 81 secant squared theta d theta. Now at the bottom, I will factorize. Take 9 outside and get 1 plus tangent squared theta and then squared. Now let's distribute this square at the bottom, and we'll get 81 secant squared theta d theta over 9 squared, 1 plus tangent squared theta. Now 9 squared is 81, so 81 cancels out, and 1 plus tangent squared is secant squared. So we get the integral of secant squared theta d theta over secant theta to the power 4. Simplify that, and we'll get the integral of 1 over secant squared theta d theta. Now, what is secant theta? It's 1 over cosine theta. So all in all, we'll get the integral of cosine squared theta d theta. Now, let's have a look if that's what we wanted to show. Yes, apart from the limits. So now let's sort out the limits. Our original integral was from 0 to 3. And the substitution we had to use was x equals to 3 tangent theta. So when x equals to 0, we get 0 equals to 3 tan theta. Therefore, theta is equal to 0. When x equals to 3, we get 3 equals to 3 tangent theta. Divide both sides by 3 and we get tangent theta equals to 1. So theta equals to pi over 4. Okay, so the integral equals to, from 0 to pi over 4, cosine squared theta d theta, and that's exactly what we had to show. Okay, shown. Let's move on to the next question. The next question is to find the exact value of the integral. So we're going to integrate from 0 to pi over 4 cosine squared theta d theta. And for integrating squared trigonometric functions, the standard technique is to replace the square with a double angle. So we can use the formula cos 2 theta equals to 2 cos squared minus 1, and I can rearrange this formula to find cosine squared. So I'm going to move 1 to the other side, and then divide it by 2. I got cosine squared theta. Okay, replace cosine squared with this expression, so we get the integral from 0 to pi over 4 cosine 2 theta plus 1 over 2. Now let's take 1 over 2 out of the integral, so we get 1 over 2, integral from 0 to pi over 4, I forgot d theta, cosine 2 theta plus 1 d theta. Now let's integrate this. So the integral of cosine is sine 2 theta. Then because we got 2 next to theta, so I'm going to divide by 2. Plus integral of 1 is going to be just theta. And our limits are from 0 to pi over 4. Let's substitute the upper limit. We get 1 over 2 times a half plus pi over 4. And then when I substitute 0, I get 0. So no need to write anything else. Okay, and for the final answer, I'll just open the brackets. Answer 1 over 4 plus pi over 8. Next question. Okay, so the next one is about complex numbers, and they're asking us to basically get rid of the fraction and rewrite it into something else. We also have a standard technique for doing that, and the technique is to multiply top and bottom of the fraction by what we call a complex conjugate of the denominator. And a complex conjugate is where I just have to replace the sign of whatever is next to imaginary part. So I'll have to multiply by 1 minus 2i. And our fraction becomes square root of 2 minus a square root of 2i times 1 minus 2i over 1 plus 2i times 1 minus 2i. Now, why does this technique work? That's because of the formula a minus b times a plus b equals to a squared minus b squared. That means at the bottom, if we use this formula, we'll get 1 squared, which is 1, minus 2 squared, 4, and then I squared is minus 1, and then minus and minus will give us plus. Now the top part is a bit more difficult. I'll just have to expand the brackets. I'll get square root of 2 minus 2 square root of 2i minus a square root of 2i plus 2 square root of 2a, and then I squared is minus 1, so times minus 1. Now let's simplify this. We will get a square root of 2 minus 2 square root of 2a over 5. That's the real part. For the imaginary part, we can take minus outside, and we'll get 2 square root of 2 plus a square root of 2 over 5 I. And that's exactly the form they were asking for. Question B. Now it is given that a equals to 3, and we have to rewrite our complex number in an exponential form. To start with, let's replace a with 3. So we will get a square root of 2 minus 6 square root of 2 over 5 minus 2 square root of 2 plus 3 square root of 2 over 5i. Simplify that, and we'll get minus 5 square root of 2 over 5 minus 5 square root of 2 over 5i divided by 5, and we'll get minus square root of 2 minus square root of 2i. Now, how do we write it in the exponential form? Let's draw an Argand diagram. X-axis is the real part, y-axis imaginary part, and our number is going to be somewhere here. So the real part is negative, imaginary part is also negative. Now r is going to be the length of this vector, and then we can find it by using the formula square root of x squared plus y squared. Root 2 squared is going to be 2. And all in all, we get 2. Now, what about theta? Theta is going to be the angle the vector makes with the real axis. Now, our angle should be in between minus pi and pi, so that way. Okay. Now, how do we find this angle? Now, we obviously have pi over 2 right here. And we also have a little triangle at the bottom. Now, let's draw this triangle separately. Here we got square root of 2. This one is also square root of 2. So that means the angle on top is going to be 45 degrees or pi over 4 radians. So theta equals to pi over 2 plus pi over 4, which is 3 pi over 4, but because we're going clockwise, this value is going to be negative. So our number is going to be 2 e to the power of minus 3 pi over 4 I. For the next question, we'll have to find the 2 square roots of that number. And in order to do so, let's have a look at the Argand diagram one more time. Real part, then imaginary, minus square root of 2. Imaginary part is also minus square root of 2. And we can think of our number as the point or as a vector. Okay, now what happens here is that we found the angle. Theta was negative 3 pi over 4. And the thing is, we can actually get to the same point if we add 2 pi radians to this angle, because that's going to be the full circle. And we can actually keep adding 2 pi as many times as we want. So we can say our angle equals to minus 3 pi over 4 plus 2 pi times k, where k is the number of circles we're willing to go in order to arrive to the same point. Now, how's it going to help us find the square root? Let's have a look. So our number equals to 2e to the power of minus 3 pi over 4, and we could say it's 2 plus pi k I. Now, exponential forms are very useful whenever we have to find square roots, because a square root is the same as raising it to the power of 1 over 2. So that gives us a square root of 2 e, and then I will have to multiply the bracket by 1 over 2. So I will get e to the power of minus 3 pi over 8 plus pi k. Now, if k equals to 0, I get square root of 2 e to the power of minus 3 pi over 8. If k equals to 1, I will get square root of 2 e to the power of minus 3 pi over 8 plus pi. And then simplifying this gives me square root of 2 e to the power of 5 pi over 8. And these two values are going to be my answers for that question. Question 8 is about implicit differentiation. We have to find dy over dx in terms of x and y. So let's differentiate the left side and the right side of this equation with respect to x. We'll have 3x squared plus 3y cubed times y derivative plus 2 times, now we're going to use the product rule, derivative of x is 1, let's get y, plus y derivative times x, and the derivative of 8 is 0, that equals to 0. And from here we'll have to find y derivative. First, let's expand the brackets. And then let's keep everything with y derivative on the left side and everything without on the right side. Next, factorize and take y derivative out of the bracket. And then divide by the bracket to get y derivative. And maybe let's put minus in front to make it look a bit better. Okay, that's the derivative. Next question. Okay, for the next question, we're going to use the derivative. And we also have two tangents that intersect at an angle alpha, and we have to find the tangent of that angle. To start with, let's think about the derivative and what the derivative shows us. Apart from many things, it shows us the gradient of a tangent line at some point. So imagine we have a tangent line, and in order to find the gradient of that tangent line, we have to draw a little triangle. Then we're going to have a difference in y and the difference in x. And the gradient of this line, which is the derivative, is going to be change in y over change in x. And if you think about this, it is actually equal to tangent of the angle that the line makes with the horizontal line. So I could say that tangent of an angle equals to change in y over change in x, which is actually the derivative. Okay, so we have 2 points, and the first one is where x equals to 0. Now, I want to calculate the value of the derivative, and in order to do so, I need to know what y is at this point. So I will look back at the equation of the curve, which is x cubed plus y cubed plus 2xy plus 8 equals to 0, and I substitute x equals to 0 into this equation, in order to find y, I will get y cubed plus 8 equals to 0. So y cubed equals to minus 8, and taking the cube root gives me minus 2. So the first point is 0, minus 2. Now, I want to know the derivative at this point. Substitute this point, and I will get minus 2 times minus 2 over 3 times minus 2 squared. So it becomes 4 over 12, or 1 over 3. And now I want to do the same for y equals to 0. Equation of the curve, again, is x cubed plus y cubed plus 2xy plus 8 equals to 0. Substitute y equals to 0. And we get x cubed plus 8 equals to 0. So that means x is minus 2, and our point is minus 2, 0. Okay, now substitute this into the derivative, and we get y derivative equals 2 minus 3 times 4 divided by 4, or by minus 4, and we get 3. Okay, so what we're going to do with these values now? Remember, the value of a derivative is actually the tangent of an angle that the tangent line makes with the horizontal line. So what happens at the point of the intersection? Let's draw a sketch. We have two lines. They intersect, and the angle of intersection is alpha. Now, what we have now is two angles. Let's say the first angle is A, and the second angle is going to be B. So what we're looking for is angle alpha, which is B minus A. And what we have is tangent A and tangent B. Let's say tan A equals to 3. And the second angle is 1 over 3. What we're looking for is tangent B minus A. Oh, actually, tangent A equals to 3, so that means my angle A is bigger than B. So let's look for tan A minus B instead. Sorry for that. Okay, and then in order to do so, we can use the formula for tangent A minus B. That's going to be tan A minus tan B over 1 plus tangent A times tangent B. And we have the value of both tangents, so all we have to do is to substitute this into that formula. So we'll get 3 minus a third over 1 plus 3 times over 3 is 1. So we got 1 plus 1 at the bottom. And if we calculate this, we get 4 over 3. And that's going to be the answer for that question. 4 over 3. Next one is about vectors. So first of all, let's put all the information we've got on the picture, so it's a bit easier to work with. OG equals to 2 units. And M is the midpoint. Okay, so first we'll have to find the vector OM. Think about it. How can I get from point O to point M, possibly using vectors I, J, and K? So what I'm going to do is to first move from point O to point A. That would be vector OA. Next, from point A, I can move up to point D. So I will plus vector AD. Then from point D, I will have to move to point M. So it's going to be plus the vector DM. Now, we know that OA is going to be 2i. Vector AD is 2k. Now vector dm, because m is the midpoint, is going to be a half of vector df, which is actually the same as the vector ac. So it's going to be a half of vector ac. Now, how can I move from point A to C using vectors I and j? It is going to be minus 2i plus 4j. Now, all I have to do is to put everything back together. So I get 2i plus 2k minus, expand the brackets, and I get minus I plus 2j. And altogether, that's going to be I plus 2j plus 2k. Now let's find vector mn. And it's very similar. So from point M, I could go to point D, then from D to A, and then from A, I can finally move to point N. Let's write all of this down. MD plus DA plus AN. And we already know almost everything. So MD is going to be minus a half times minus 2i plus 4j, and then minus 2k plus 3 over 4j. Okay, expand the brackets, so it's going to be I minus 2j minus 2k plus 3 over 4. Oh, I forgot to multiply by 4 because 4 units plus 4j. Okay, and then simplifying that gives us I plus j minus 2k. So we found both vectors. Let's move on to the next one. Next question is about the vector equation of the line going through M and N. Okay, so what I have to do is first write down the position vector of any point on this line, and I think I'm going to choose the point M. So vector equation equals to OM plus some number, I'm going to call it lambda, times a vector which is on this line. I'm going to choose vector MN. And we already know two vectors, OM and MN. I'm going to write it as 1, 2, 2 plus lambda. And vector MN is 1, 1, minus 2. That's it. Okay, next question is to find the length of the perpendicular. And whenever we have a question about something perpendicular and vectors, that immediately brings us to the dot product. But first of all, I want to draw a sketch to make things a little bit more clear. We have the line MN, and we already have the equation for this line. Somewhere there's point O, and we have a perpendicular. And let's say this perpendicular intersects MN at point P. So now, because the two lines are perpendicular, that means the dot product of the vector OP and the vector MN should be 0. Now, we already have the equation of the line MN, and let's say for the particular value of lambda, we get the point P. And I want to know this value of lambda. So using that equation, I could say that OP equals to Let's have a look at our equation. It's 1, 2, 2. Plus, let's multiply this factor by lambda. We get lambda, lambda, minus 2 lambda. Lambda, lambda, and minus 2 lambda. Now combine this together, and we get OP equals to 1 plus lambda, 2 plus lambda, and 2 minus 2 lambda. And we already know vector Mn. It is 1, 1, minus 2. Now let's calculate the dot product of OP and Mn. It's x times x plus 1 y times y plus z plus z. So I will get 1 plus lambda plus 2 plus lambda minus 4 plus 4 lambda, and that must be equal to 0. So from here, I can find lambda. 6 lambda minus y equals to 0, so that means lambda is 1 over 6. Okay, that means the position vector of that point is OP equals to, all I have to do is to substitute lambda, so it gets 7 over 6, 13 over 6, and 5 over 3. Now, I'm looking for the length of this vector, so I have to do the square root of x squared plus y squared plus z squared. Okay, so let's substitute all of that, and we'll get 7 squared plus 13 squared. Okay, instead of writing 5 over 3 squared, I think about it as 10 over 6, so I get plus 10 squared over 6 squared is 36, and don't forget the square root. Simplify that, and we'll get the square root of 318 over 36, or if we simplify it, it's going to be 53 over 6. Let's have a look. Yes, that's exactly what we had to show. Okay, time for the last question. We have a curve and there is a stationary point, and immediately when we see the stationary point, we can think that the derivative at that point, a, must be equal to 0. So that means we'll have to differentiate the equation y equals to x, and I will replace the square root with the power of 1 over 2. Now let's differentiate it using the product rule. So y derivative equals to u derivative times v plus v derivative times u. And using the product rule, we got derivative of x is 1 times v sine x to the power of 1 over 2. Next, v derivative. We have to use the chain rule, so I'm going to differentiate the power first. I get 1 over 2 times sine x, subtract 1 from the power, and I get minus 1 over 2 times the derivative of the inside function, which is cosine x, then multiplied by u, which is x. Now, y derivative, when we substitute x equals to a, is going to be, I will replace the power with the square root back again. So get square root of sine a plus a cosine a over 2. And then the negative power of the sine means it's going to go down to the fraction, and we get square root of sine a. And that should be equal to 0, because when x equals to a, we have a stationary point. Okay, now we'll have to rearrange this equation and show that tangent a equals minus a half a. Okay, so what I'm going to do is to multiply both sides of the equation by 2 square root of sine a. Okay, so that gives me 2 sine a plus a cosine a equals to 0. Now we need to get a tangent in our equation, so I will divide both sides by cosine a. That gives me 2 tangent a plus a equals to 0. Now rearrange it, get tan a equals to minus a over 2. And that's exactly what I had to show. Now, next question. Verify by calculation that a is in between 2 and 2.5. Okay, so to start with, let's copy the equation. Tan a equals to minus a over 2. Now, first of all, I'm going to substitute a equals to 2. So I'll get tangent 2. And then on the right side of the equation, I'm going to have minus 1. Now, because a equals to 2, but a equals to 2 is not the actual solution of this equation. Why? Because tangent 2 is minus 2.18. By the way, don't forget to switch your calculator to radians. And then minus 2.18 is obviously less than minus 1. Now, if a equals to 2.5, let's substitute 2.5, and we'll get tangent 2.5. And then on the right side, we get minus 2.5 over 2. Now, tangent 2.5 is minus 0.75, and then minus 2.5 divided by 2 is minus 1.25. Now, in that case, the left side of the equation is bigger than the right side. Okay, now we have to verify by calculation that a is in between 2 and 2.5. Now, so here's the point. If a equals to 2, then the left side is smaller than the right side. If a equals to 2.5, we have the opposite. Left side is bigger than the right side. So that means if a is somewhere in between 2 and 2.5, the left side must be equal to the right side. And don't forget to write this as some kind of conclusion, because if you do forget, you will lose 1 mark for that. And normally the standard kind of phrase Cambridge is looking for is change of the sign of the inequality indicates the presence of the root. So I'm just going to write it down. Change of the inequality sign indicates the presence of the root. Okay, and we are ready to move to the next question. Right, so we have a sequence and we have the iterative formula for the sequence. Now we have to show that if the sequence is converging, then it should converge to the value of a, which is given by the equation in part A. By the way, let's have a look at what it says. So it should be tangent x equals to minus x over 2. Now let's have a look at the formula and just write it as x equals to pi minus inverse tangent of x over 2. Now we'll have to rearrange this equation to get tan x equals to minus x over 2. Okay, let's move the inverse tangent to the left. And then x to the right. Now, I want to get rid of the inverse tangent, so I will take tangent of both sides. Now, tangent and the inverse tangent will cancel out, so I'll get x over 2 equals to tangent of pi minus x. Now, here we have two ways of dealing with tangent of pi minus x. And the first one is to use the formula tangent a minus b. Or we can do it a bit simpler, because we know that the graph of tangent repeats itself after every pi radians. So that means x over 2 is going to be the same as tangent of minus x. And we also know that tangent of minus x will be equal to minus 10x. And then we can multiply both sides by minus 1, and we'll get tangent x equals to minus x over 2, which is exactly what we had to show. Now let's move on to the next one. Now we have to use the iterative formula given in part C, which is x n plus 1 equals to pi minus inverse tangent of xn over 2, in order to find the value of a corrected to decimal places. Right, so I'm going to use the table. I will draw xn, and then the next value of x n plus 1. Okay, in the previous part, we know that a is in between 2 and 2.5. So my starting value is going to be, I'll just take the mid value, 2.25. And I will have to substitute xn into the formula above. And that gives me 2.29743. And that becomes my new value of xn. So I'll just copy it down, and then I substitute this value of xn into the formula again. I get 2.28709, and I'll just repeat the process. I get 2.28932, and I have to find a corrected to decimal places. Now, these two values are actually the same, corrected to decimal places. So that means I already have the answer, which is to the two decimal places is 2.29. Okay, and that was the last question. I hope you find this video useful. Bye!